Hi students, welcome to Max Point of View. Now we have learnt work, energy and power part A completely, correct? We have learnt all the concepts in part A. Now we are going to solve each and every question which is there in the textbook. And the numericals, again we are going to solve each and every numericals, and that video will be available in the description box. And the concept video, if you want to understand what is work, energy, power and different conditions, for that we have made a video separately, and that is what we have learnt in the previous session. That video will also be available in the description box. A force F acts on a body and displaces it by a distance s in a direction at an angle theta with a direction of force. So this is the statement they have given. Now we'll see the question. Write the expression for the work done by a force. Second one, what should be an angle between the force and the displacement so that the work done is 0 and maximum. So here we have two questions, correct? If you have understood the concept, that is what I am saying. If you haven't seen it, please watch it and come, then only you will understand it properly. If you don't see that, okay, if you don't know the basics of work done, power and energy, then it will be little difficult. So my suggestion will be just watch that video and come. That will be available in the description box. Okay, listen. First, write the expression for work done by a force. Listen, they are telling force is applied and the object is moving and there is an angle between them. Okay. Now, I'll take a same example. The previous question. In the previous question, we have taken one example, right? Okay, listen. I am applying a force in this direction. Okay, instead of moving in this direction, this object, okay, assume there is an inclined plane. It is going to move in this direction. So, they are telling your force is applied in one direction and there is an angle theta between the force applied and a displacement. So what is the expression we are going to use? Whenever there is a angle, whenever there is a theta, we have to use W is equal to F into S into cos theta. Okay, if both are in the same direction, if force applied and the object moved, okay, both are in the same direction, then there will be no theta. Then only expression will be how to find the work done. Work done is equal to F into S. That's it. Okay. Now we have a theta, that is why we have an angle between the force applied and the displacement. That is why we are using cos theta. So this is the answer for the first one. Second sub question, what should be angle between the force and the displacement so that the work done is 0 and maximum? When we can say work done is 0, there are two conditions, correct? Even though you apply a force, there will be no movement from the object, then work done is 0. And one more condition, when the angle between the force applied and the displacement is 90 degrees. So that is what they are asking. If we are using the expression, when we can say the work done is 0 and work done is maximum. See, for 0, when we can call work done as 0, that is nothing but when theta is equal to 90 degree. Okay, when theta is equal to 90 degree, work done will be 0. How is that possible? What is theta is equal to 90? That is nothing but cos 90. What is cos 90? Cos 90 is 0. Anything multiplied by 0 will be 0. So work done will be 0. So when is the work done is 0? When theta is equal to 90 degree, or even though you apply a force, when there is no movement from the object. If the object is not moving, then also we can call it as work done will be 0, but here they are expecting expression, correct? That is why we have to write when theta is equal to 90 degree. And when it is maximum, when theta is equal to 0 degree. How theta can be 0? Very simple example, listen. Assume you are applying force in this direction and the displacement of object is also in the same direction. Now listen, see what do you mean by theta? Angle between force and the displacement. If force and displacement are in same direction, angle will be 0. So when it is 0, what is cos 0? Cos 0 is 1, correct? 1 into whatever the value will get the same value. So we will get the maximum value only when theta is equal to 0 degree. A body is moved in a direction opposite to the direction of force acting on it. State whether the work is done by the force or work is done against the force. Okay, listen, very simple question. Whenever the direction of force is exactly opposite to the direction of displacement, then the work done will be negative. In that kind of situations, work done will be against the force. How? We are going to see with the example. Listen. Assume a ball is rolling on a floor. What do you mean by rolling? It is nothing but moving. Moving is nothing but the displacement. Whenever an object is moving on a floor or it is in contact with the floor and it is moving, then the displacement will be in this direction. If the displacement is in this direction, frictional force. What do you mean by frictional force? Opposing force, correct? Opposing force will be in this direction. If this ball is moving in this direction, then the frictional force will be in this direction, exactly opposite. Whenever these two are opposite, okay, see, force is in this direction, okay, then displacement is in this direction. Then what will be the angle between them? Theta will be equal to 180 degree. Okay, if theta is equal to 180 degree, work done will be negative. Okay, if the work done is negative, or else if the angle between them is 180 degree, or if the direction of force and the direction of displacement are opposite, then work is done against the force. See, work done is nothing but displacement of an object, correct? It is done against this force. So it may be any force. It may be friction force or gravitational force or any other force. Okay, work done will be against the force. State whether work is done or not by writing yes or no in the following cases. A man pushes a wall. Listen, a man pushes a wall. Whenever he is pushing, it is nothing but he is applying a force. He is applying a force in this direction. But do you think this wall is moving? No. Then if wall is not moving, displacement will be 0. If displacement is 0, work done will also be 0, correct? So work done is 0. What is the reason? There is no displacement. Okay, here, see the second question. A coolie stands with a box on his head for 15 minutes. If it is 15 minutes or an hour or 24 hours, okay, he is not moving, correct? There is a force. Force is nothing but the weight of this luggage that will be in downward direction, correct? Weight of this luggage will be acting downward direction. There is a force, but he is not moving, correct? If he is not moving, there is no displacement. Now he is not moving, there is force, but there is no displacement. Therefore, as in the first case, the work done is again 0. Why? No displacement. No displacement, that is why the work is 0. Next, a boy climbs up 20 stairs. Assume a boy climbing a stairs. It may be 20 or 40 or 100. He is moving, he is climbing, right? So he is applying some force. Force is nothing but the weight of the boy that will be in downward direction, and he is moving. So we have a force and there is a displacement. We have a force and displacement. That is why we have work done. So work done is, yes, there is work done. Okay, in both the cases there is no work done. So you can write it as no as an answer. Here also no. Okay, here we have yes because there is a force and there is a displacement. Give an example when work done by a force of gravity acting on a body is 0, even though the body gets displaced from its initial position. Okay, very simple question. We have seen this question so many times. Now also I am going to explain. Listen, they are asking for work done is 0 even though there is a displacement. They are asking for an example. Listen, a person who is carrying a luggage, he is walking on a horizontal ground, straight horizontal ground. Now he is moving in this direction, correct? Now the luggage, okay, I'm using all the diagrams just to explain it. Don't write all these diagrams in the exam, you can just explain it, that is enough. Okay, listen, the weight, the luggage weight is nothing but the force, correct, that will be acting in downward direction, and the displacement is perpendicular to the direction of force, correct. Now if it is perpendicular, that is nothing but 90 degree. When the work done is 0, when cos theta is equal to 90 degree, correct. So when cos theta is equal to 90 degree, there will be no work done. So how can you write it in the exam? Okay, a coolie or a person carrying a luggage on his head walking on a horizontal ground, that is an example for work done is equal to 0 when there is a displacement. Why? Because the direction of force and the direction of displacement are normal to each other. That's it. A boy of mass m climbs up the stairs of vertical height h. Okay, a boy has mass and they are also using h, correct, mass and height they are giving. Now the first question is, what is the work done by the boy against the force of gravity? Exactly similar to the previous question. So work done will be nothing but force into displacement. Here we are talking about mass of the boy, so instead of force we have to convert this mass into weight. How can we convert mass into weight? In the previous question we have learnt mass into acceleration due to gravity will give us the weight of the boy, that is nothing but m into g. Here he is using the height word, so we have to use h and m g h, but we have to put minus symbol. Why? Because he is climbing the stairs, that is against the gravity, we have to use minus mgh. Next, second question, what would have been the work done if he uses lift in climbing the same vertical height? See, whether he is flying or using a staircase or using a lift, in all these cases work done is against the gravity, that is why we have to use negative sign or negative symbol. Now they are asking what is the work done expression whenever he uses a lift. Again, whether he uses lift or staircase, the expression remains same. For both the cases, work done is equal to minus mgh. What physical quantity does the electron volt measure? How it is related to the SI unit of that quantity? Okay, very simple. Electron volt measures the electrical energy. Why we are using electron volt as a unit? That measures electrical energy. Next, how it is related to the SI unit of that quantity? That is nothing but how is 1 electron volt related to joule. Okay, that is nothing but 1.6 into 10 power minus 19 joule. Okay, 1 electron volt is equal to 1.6 into 10 power 19 joule. Complete the following sentences. 1 joule is equal to dash calorie. Listen, 1 joule is equal to 0.24 calorie. Okay, then second one, 1 kilowatt hour in terms of joule. 1 kilowatt hour in terms of joule. Okay, that is nothing but 3.6 into 10 power 6 joules. How we got this one? Very simple. See here, first I'll write this watt in terms of joule. 1 watt is equal to 1 joule, correct? 1 watt is equal to 1 joule. Next, 1 hour is equal to how many seconds? 1 hour is equal to 3600 seconds. 1 hour is equal to 3600 seconds. Then what do you mean by 1 kilo? That is nothing but 1000, correct? Kilo is nothing but 1000, correct? So 1000 into 3600 into 1. So that is nothing but 3600. How many zeros left? 1, 2, 3 joules. So that is nothing but 3.6 into 10 power 6. So the decimal point is here. It has moved 6 times. That is why 3.6 into 10 power 6 joules. That's it. Name the physical quantity which is measured in calorie, how it is related to the SI unit of that quantity. So they are asking which physical quantities is measured using calorie. Heat energy is measured using calorie, correct? So heat energy, first option, first sub question is heat energy. Okay, second sub question, they are asking how it is related to the SI unit of that quantity. So 1 calorie is equal to how many joules? That is nothing but 4.18 joule. 1 calorie is equal to 4.18. Name the physical quantity measured in terms of horsepower. So horsepower is used to measure what? Power. So the physical quantity measured in terms of horsepower is power. So the first answer is power, and they are asking how is related to that quantity. That quantity is nothing but the power. So HP, how HP is related to power? What is the unit of SI unit of power? Watt. What is 1 HP? That is nothing but 746 watt. That's it. Name the quantity which is measured in first one kilowatt hour, second one kilowatt. See, in the previous question itself we understood watt hour is a unit of energy, correct? When it is only watt, okay, it is the unit of power. When it is with the time, okay, power into time will give us energy. So watt hour is the unit of energy. Kilo, don't worry about this word kilo. What do you mean by kilo? It is 1000 watt hour. If it is 1 watt hour or 1000 watt hour, it is the unit of energy. In the same way, so don't worry about this kilo, mega and all those things. Watt is a unit of power. If kilowatts, what do you mean by kilowatts? 1000 watt. If it is 1000 watt or 1 watt, it is the unit of power. Next one, okay, C and there is D. C is watt hour, D is electron volt. See, whenever compare these two, A and C, this is kilowatt hour, this is watt hour, this is 1 watt hour, this is 1000 watt hour. So SI unit will not change with the number, it remains constant, only the number changes. Watt hour is a unit of energy. Next, electron volt. Electron volt is also electrical energy. Electrical energy, so it is related to energy. Electron volt, watt hour, kilowatt hour are the units of energy. Only watt is unit of power. That's it. Is it possible that no transfer of energy takes place even when a force is applied to a body? Very simple. So even though there is a force applied on a body and the body is moving, there will be no transfer of energy only when the angle between the force applied and the displacement is 90 degree, or the direction of force is perpendicular to the direction of displacement. Whenever any one of these cases is true, then there will be no transfer of energy. Define work. When is work said to be done by a force? Okay, very simple question. Definition of work they are asking. What do you mean by work done or work? Work done is nothing but the product of force applied on an object and the displacement of the object in the direction of force. So this is the definition of work. Then they are asking one more question. When is work said to be done by a force? Okay, listen, if you understand the meaning of that question, the answer is hidden in that question only. Listen, when the work is said to be done by a force, when the force displaces the object. See, whatever the force you are applying, if that force displaces the object, then it is said the work is done by the force. How is the work done by a force measured? When first one, force is in the direction of displacement, force is at an angle theta to the direction of displacement. So in one question there are two sub questions. They are asking how we can measure work done, which is the first sub question. Okay, listen, if you understand it, or if you can imagine it in the form of a picture, then it is easy to analyze it. If you apply a force on an object, if it moves in the same direction, how we can measure the work done? Second sub question, assume you are applying a force in this direction and it is an inclined plane. Okay, if you apply a force in this direction, it is not going to move in this direction, correct? It is going to move in this direction. So there is an angle theta. For this example, how we are going to measure the work done? So these are the two sub questions. Listen, very simple. If you have understood the concept video properly, which I thought, if you haven't seen it, that video is available in the description box. First watch that and come. If you watch that, then you can aram-se solve all these questions. Now see, if the force is applied in this direction and the displacement of the object is also in the same direction, then work done will be is equal to product of force into displacement. Okay, now here there is no angle, correct? Because the force applied and also the displacement both are in same direction. If both are in same direction, there will be no angle, there will be no theta. If the directions are different, okay, small change in the direction, then there will be a theta. For this one, work done will be F into S into cos theta. Okay, this theta will be given in the question. Okay, don't worry about theta. All the theta values will be very standard, which you have learnt in trigonometry. I think you remember the trigonometry angle table, right? Sin 30, cos 45, all those things. Only the standard angles will be given. According to that, you have to put and get the value. A body is acted upon by a force. State two conditions when the work done is 0. See, for question number 4. So for this one we have two conditions, correct? When we apply a force on an object and if the object is not moving, then work done will be 0. Second one, okay, when the angle between the force applied and the displacement is 90 degree. Okay, these are the two conditions where we are going to get the work done value as 0. When a body moves in a circular path, how much work is done by the body? Give reason. They have given one hint also. The body is acted upon by a centripetal force. Okay, whenever the object is moving in a circular path, assume this is an object and it is moving in a circular path. Okay, now we have to talk about two things. One, force. So for a centripetal force, what will be the direction of force? Very simple. For centripetal force, the direction of force will be towards the center. This is the center, right? For centripetal force, the direction of force will be towards the center. Okay, now we are talking about this point, correct? This point. Okay, at this point, if the object is moving anti-clockwise direction, at this point, the direction of object will be here, right? The direction of object will be here. So this is nothing but displacement. Now we can aram-se say the angle between them is 90 degree. When the angle between the force applied and the displacement is 90 degree, work done will be 0. Work done will be 0. Why? They are asking for reason. Why work done is 0? The reason is angle between the force applied and the displacement is 90 degree. That's it. A satellite revolves around the earth in a circular orbit. What is the work done by the satellite? Give reason. See, in the previous question, 7th question, we understood that whenever there is a circular path, work done will be 0. Okay, in this case, how we can write the answer? See the first question, what is the work done by the satellite? Work done by the satellite is 0 because the gravitational force, the direction of because the angle between the gravitational force because the force and the displacement are perpendicular to each other, or else you can say the angle between the force and the displacement is 90 degree. That is why work done is 0. A coolie X carrying a load on his head climbs up a slope, and another coolie Y carrying an identical load on his head moves in the same direction on a frictionless horizontal platform. That frictionless is very important word. Who does more work? Explain the reason. Very simple. assume this as coolie x and this as coolie y. So this person, this coolie x is moving on an inclined plane. So we have an angle, correct? We have an angle. So he is applying the force in this direction. Okay, this is force and this is displacement, correct? This is force applied and this will be displacement. So there is a change in direction, that is why we have an angle. Now what will be the work done by this coolie x? Okay, work done by the coolie x. Okay, you have to write it, okay, in the full form. Work done in the bracket x will be, he is applying force, yes, and there is a displacement, yes, and there is an angle, correct? We don't know the value of this angle f and s, so we are going to get some value, correct? The work done will not be 0, correct? Why? Because if it is perpendicular, if it is 90 degree, okay, if the angle between the force applied and the displacement is 90 degree, then there will be no work done, correct? But the angle is not 90 degree, somewhere between 0 to 90 degree, so there will be some work done, correct? Now we'll talk about second question. Okay, here the important word is frictionless platform. Frictionless platform. Okay, assume there is no friction. What do you mean by frictionless platform? There is no friction, that means he has a luggage. Okay, luggage is nothing but force. The weight of the luggage is nothing but force that will be acting in downward direction, correct? Okay, now listen, there is a luggage that will be acting in downward direction and the coolie is moving in this direction. Okay, that is nothing but displacement. What is the angle between these two? These two are perpendicular, right? These two are normal to each other, perpendicular, or you can use it as theta is equal to angle between the force applied and the displacement is 90 degree. So what will be the work done? W is equal to F into S into cos theta. This is the normal formula. So whenever F into S into, what is cos theta? Cos theta is nothing but 90 degree. What is cos 90? Cos 90 is equal to 0. So anything multiplied by 0 will be 0. Anything multiplied by 0 is 0. Now there is no work done. What is the work done value? 0. Okay, so compare these two. Who has done work? Some work. So coolie x has done more work than coolie y. So the important word in this question is frictionless platform. What if there is a friction? What if there is a friction? Assume this is not frictionless platform. See, whatever I am going to write now, this is not related to the question number 10. Now listen, assume there is some friction. Okay, there is some friction. So this will be displacement and this will be force. Both are in opposite direction. Then theta will be 180 degree. What is cos 180? Cos 180 is nothing but minus 1. So whatever the work done we are going to get, that will be negative. So if there is a friction, so in this question he is clearly mentioned that frictionless platform. So friction will be 0. Correct, friction will be 0 and there is a force in downward direction and displacement in right towards right direction. So angle between them is 90. That is why work done is equal to 0. The work done by a fielder when he takes a catch in a cricket match is negative. Explain. Very simple question. See, this is why so logics are very much important. Few examples are given in the textbook. That is what we have learned during the concept. See this question. This is a different example. These are called as application oriented questions. If you know the logic properly, then answering these kind of question is very easy. Assume you are that person, you are catching a ball. Okay, so whenever the ball is coming in this direction, you will apply a force in this direction. In which direction you are applying a force? To catch the ball, you have to apply like this, right? So the force applied is in this direction, but ball is coming in this direction. So the force applied is in this direction, ball is coming in this direction. That is nothing but, yes, correct. So both are in opposite direction. Both are in opposite direction. Then if force applied and the displacement both are in opposite direction, then theta will be 180 degree, correct? See, force applied is in this direction, the displacement, okay, is in this direction. So both are in opposite direction. The theta angle between them is 180 degree. Correct. Angle of a straight line is 180 degree. Now we'll apply that in the formula. What is the formula? Work done is equal to force into displacement is into cos theta. Force into displacement into cos theta. Cos 180 is equal to, that is minus 1. So whatever the work done value we are going to get, that will be negative. What are the SI and CGS units of work? How are they related? Establish the relationship. Okay, it's a very easy question. First we need to write the SI unit and then CGS unit. We have to show them how they are related and we have to show the working also. That is nothing but establish the relationship. Okay, what is the SI unit of work done? It is joule. This we have learnt in concepts. Correct. Then CGS unit of work done is erg. Correct. So SI unit of work done is joule and CGS unit of work done is erg. Then 1 joule is equal to 1 Newton meter. Correct. According to the formula of work done, the unit is Newton meter. SI unit is 1 joule. 1 joule is equal to 1 Newton meter. 1 Newton meter. What is the CGS unit of Newton meter? CGS unit of Newton is dyne. CGS unit of meter is centimeter. How they are related? So 1 Newton meter is equal to 10 power 7 dyne centimeter. Then 1 dyne centimeter is equal to 1 erg. Now we have the relationship between dyne centimeter and erg, but we want the relationship between joule and erg. So 1 dyne centimeter we got to know that is equal to erg. Dyne centimeter is related to Newton meter. This Newton meter is related to joule. So how can we derive the relation between joule and erg? 1 joule is equal to 1 Newton meter. Correct. From this one. Next. So 1 joule is equal to 10 power 7 dyne centimeter. Correct. Because 1 Newton meter is equal to 10 power 7 dyne centimeter. 1 joule is equal to 10 power 7 erg. Why? Why? Because 1 dyne centimeter is equal to 1 erg. If dyne centimeter is equal to erg, then 10 power 7 dyne centimeter equal to 10 power 7 erg. This is the relationship between joule and erg. State and define the SI unit of work. Very simple question, but you need to understand the difference between state and define. State means you just have to write that word. Define means you have to define that. You have to write the definition. That's it. So they are asking to state, right? What is the SI unit of work done? That is nothing but joule. Okay. There is one more question. We have to define 1 joule. See, whenever we are defining a unit, we have to talk about 1 joule. Okay. We have to use this word 1 joule. Okay. This is for work done. Now we'll define it. 1 joule of work done is when force of 1 Newton displaces a body through a distance of 1 meter. So everything will be in 1. Okay, number 1. That's it. We have already done in question number 13. We have derived the relationship between 1 joule and erg. Correct. That is done in question number 13. Define the term energy and state its SI unit. Here they are asking you to just state it. Just write the SI unit. If they are asking you to define the unit, then you have to write it in the definition form. Okay. State the term energy. What do you mean by energy? Energy is nothing but the capacity to do work. What is the SI unit of energy? Again, SI unit of energy will be joules only. Define the term power. State its SI unit. What do you mean by power? Power, there are two types of power, mechanical power and electrical power. In this chapter, we are not talking about electrical power. We are talking about mechanical power. So, power is nothing but this is the formula, correct? But if you write like this, they are not going to give you any marks. So how can we define? Power is nothing but rate of change of work done. Rate of change of work done. They are asking for SI unit. What is the SI unit of power? That is nothing but watt. Watt is the SI unit of power. Differentiate between work and power. See, if you know what is work and what is power, aramse you can write the differentiation. And in physics, the difference between any two physical quantities or anything will be asked for maximum 3 marks. So if you write 3 points on each side, that will be enough. So what is the first point? For work done, for work and power definition. Okay, so definition of work and definition of power, if you write as one point, then it is enough, because I am not writing here. Why? Because we have discussed this one so many times. Then second point, work done is independent of time. Independent of time. Okay, power depends upon time. Depends on time. Now the final point, the SI unit. If you write the SI units, then that is enough. SI unit of work done is SI unit is joule. Here it is watt. Okay, so I have used short forms. If you write it in a full form, that is enough. If you write 3 points on each side, then you will get definitely 3 marks. Here they are asking for differentiate between energy and power. See, differentiation between work and power and energy and power is almost similar. First point, on both the sides we will write the definition, correct? Second point, you can aramse write energy is independent of time, power depend upon time. Next, the third point, SI unit of energy is joule, SI unit of power is watt. That's it. See, the same thing here. Instead of this one using work done, we are using energy, and the definition is different. That's it. State and define the SI unit of power. So state means just you have to write the word. For the state, the SI unit of power is watt. Now we have to define what is this watt. We should not define what is power. See, understand the question. State and define the SI unit of power. They are not asking define power. They are asking you to define the SI unit of power. SI unit of power is watt. Now we have to define it. 1 watt of power spent is equal to 1 joule of work done in 1 second. That's it. That is the definition of SI unit of power. Differentiate between watt and watt hour. Okay, what is watt? Watt is a SI unit of power. Then what is watt hour? Watt hour is a SI unit of energy. So what is the differentiate between watt and watt hour? One difference is enough. So watt is the watt. Watt is the SI unit. WATT is the SI unit of power, and watt hour is the SI unit of energy. That's it. If you know these units, then it is easy to find the physical quantity. State the condition when the work done by a force is positive and second one is negative. Explain with the help of example. Okay, very easy question. Listen. First one, when we can call the work done as positive, the angle between the force applied and the displacement is 0. Okay, or when the object moves in the same direction, okay, same direction as force applied, then the work done will be positive. First one. Okay, first sub question, or else you can write this one as when the angle between the force applied and the displacement is 0 degree. So now I'll explain it with an example. That is the statement. Example, when we push a table, the table moves in the same direction as the force is applied. See, if you push the table in this direction, the table is also moving in the same direction. Then that is an example for the first sub question. Second one. Okay, for second one, we have to tell them when the work is negative. See, when the work done is negative, when the angle between the force applied and the displacement is 180 degree. 180 degree. So for that example, assume you are throwing a ball. Okay, ball is moving in this direction. Ball is moving in upward direction. So what can we call that as? Displacement, correct? Displacement. But what about force? See, force is not what you are thinking. Force is nothing but the weight of the body. Weight of the body that will be in downward direction, correct? See, force is nothing but the weight of an object. Displacement is nothing but in which direction the object is moving. So object is moving in this direction, force is in downward direction. So this is nothing but a straight line. What is the angle of a straight line? 180 degree. So theta is equal to 180 degree. That's it. See, when it comes to examples, they are not expecting for the examples which is there in the textbook. You can also use your own example. You can create your own examples, but make sure it is suitable and you are using all the keywords like force applied, the direction of force applied, the direction of displacement, angle between those two. All those things are very much important. A body of mass m falls down through a height h. Obtain an expression for the work done by the force of gravity. Here they are not asking for an expression. You have to derive the expression and it is very easy. So we are talking about work done, correct? Work done is equal to F into S. In the exam, don't write the short forms, use the full form. Now just to save the time, we are writing in the shortest form. Okay, listen. We know we are going to calculate the expression for work done. Then see, whenever something is falling down, that is because of gravity, correct? That is because of gravity due to its weight, correct? So how can we write force in terms of weight? Force in terms of weight, that is nothing but mass into gravity. So when you multiply gravity value, the present gravity value of that particular place with the mass, that becomes weight. I already told you weight is nothing but force, correct? So force we can write it as mg, and here they have mentioned height, correct? Height, it is not a displacement, it is not going from one place to another place. We are talking about height. So instead of s we have to use h. Why? Because that is mentioned in the question. So final work done expression will be mass into acceleration due to gravity into height. That's it. State two factors on which power is spent by a source depends. Explain your answer with an example. Very simple question. Listen. First thing, we have to write the factors affecting power, correct? What is the formula for power? Power is equal to W divided by T, correct? So these are the two factors affecting the power. What is that? Work done, then time taken to complete that work. Those are the two factors affecting power. Next, they are asking for an example. Assume there are two persons, A and B. They are carrying a same load, and they have to keep this load to the first floor. See, they have the same load, they have the same distance, correct? Now the condition is person A takes 30 seconds and person B takes 40 seconds to do the same job. Now tell me, who has done more work? Okay, this will be one more question that is not asked here. Who has done more work? Both person A and person B does the same work, because work done does not depends upon time, but power depends upon time. You have to keep this in mind. Work done does not depends upon time. If you take 1 hour or if you take 5 hours also to do the same work which has completed by the person A, okay, is 30 seconds and you have done the same job in 3 hours, the work done will be same, because work done does not depends upon time, but we have to talk about power, correct? So in both the cases work done is same, but the time taken by the person A is 30 seconds and it is comparatively less than the person B. That is why power spent by the person A is more than the power spent by the person B. So power A is greater than power B. You got my point? Now we have completed all the questions which is there in the textbook. The remaining thing is numericals. Numericals, again I am going to do it in a separate video. That video will be available in the description box. Thank you.